Hello, my name is John Kelly and this is the Weber Auto YouTube channel. Today we are continuing our precision measuring equipment and procedures series of videos, and I want to talk about torque wrenches, the differences, a little bit of history and proper care and usage of different types of torque wrenches. So to begin with, if we look back in history, not that long ago, for an old guy like me, back, if you look in service manuals, even from the as late as the 1960s, they did not use a traditional torque wrench as you were used to seeing today for rear axle work, for various types of work, although they did exist as early as the early 1900s, as far as I can see. But for axle work, we use a torque wrench to measure the rotational torque of, say, the preload on the pinion bearings, the preload on the side bearings, and so on, to set up the differential properly. So depending on what book you look in, it could have called for a different type of tool setup than just a torque wrench that you might have seen before, the old style torque wrenches. So to begin with, torque, there are several units of measure for torque, but they all involve the length of a lever and a certain amount of force that you're putting on that lever. So if we're talking about 1 foot-pound, we would talk about a lever that's 1 foot in length, and you would put 1 pound of mass or weight on the end of that 1 foot lever, and that would be 1 foot-pound. If you put 2 pounds on it, that would be 2 foot-pounds, and so on. So an early version of a torque wrench involved some sort of a lever like this one right here. Now this lever is actually used for holding differential pinion flanges from rotating, but it also can be used for measuring rotational torque if the differential is pointing straight up in a holding fixture. Well, an interesting thing I discovered about this old tool here is that there are some notches on the edge of this tool. So these 3 notches right here. Well, it turns out the measurement from that center notch all the way to the center of this hole right here is exactly 1 foot. So if I take a tape measure and I go from the center of that hole right there right to that center notch right there, I get 12 inches. Right there, 12 inches. So for a 1 foot measurement, there's our lever length. And then the service information asks you to get and bring in a spring scale, kind of like a fish scale, except these come in a whole bunch of different tensions available. This one goes from 0 to 50 pounds, and this one goes from 0 to 4 pounds. So let's say we wanted to put 4 pounds of force on a 1 foot lever. That would give us 4 foot-pounds of torque. And so these outer 2 notches right here in this bar are for the levers of this special service tool to come in and sit in those 2 notches, and then you would physically pull on the spring lever and turn the rod or turn the lever until you reached whatever tension level you wanted. So you could, depending on what spring scale you had, you could put whatever tension on there. So they didn't really call it a torque in the service manual. They said it should require, with this lever on there, with this tool right here, it should require so many pounds of force to rotate a properly preloaded bearing, or whatever it is that you're measuring. All right, so that's a foot-pound of tension. Now, I stumbled across on eBay an old, what looks like a torque wrench, but let me zoom in so you can read what it says. This is from 1939, this tool. And notice it calls it a tension wrench. So it wasn't a torque wrench, it was a tension wrench. And it looks just like the flexible beam torque wrenches that we have today. It has this center beam that would swing to the left or to the right, depending on how much tension you put on the 3/8 drive head out here. So this was an early torque wrench, and it was actually called a tension wrench. And this would go from 0 to 25 foot-pounds, it says right there, of torque. Modern torque units are in Newton meters. Now, a meter, as you know, is a certain length, and Newton is an amount of force. So Newton meters, foot-pounds, there's a bunch of other ones. If you get some of the new fancy electronic torque wrenches, I think there's 4 or 5 different units of measure that you can pick from. All right. So I wanted to give you a little bit of history so it would make sense as to what a foot-pound is. Now let's talk about inch-pounds. There are 12 inches in a foot. So when we talk about measuring torque in inch-pounds, then we're talking about a length of 1 inch over here and putting 1 pound of force, or 1 pound of weight on that at the 1 inch long lever. So that's a much smaller increment. That's for very small amounts of torque. An inch-pound is 12 times less than a foot-pound. And of course, you probably all know that the longer the lever, the longer your ratchet or extension, the easier it is to turn something. The shorter it is, the harder it is. And so the short ones don't give you as much leverage or as much torque. And so we use inch-pounds for a lot of things. Rotational torque on pinion, preloaded bearings, valve body bolts. There's a whole bunch of, if it's a little tiny bolt, chances are it's going to be in inch-pounds rather than foot-pounds of torque. All right, now let's get the historical torque wrenches out of the way, and let's bring in the ones that I have here in my classroom for you to use. So the torque wrenches of today basically can be divided up by their price. I have what looks like the old tension style torque wrench. These 3 right here, these all measure inch-pounds. The differences are the smallest one, this one right here, goes from 0 to 25 inch-pounds. This one goes from 0 to 50, and this one goes from 0 to 100. So you want to make sure you pick the right one for what you are measuring. Now, I also have some bigger ones that are in foot-pounds. Now, these can be accurate, but you need to read the instructions that come with them, or the specifications that come with them. I want you to notice that the modern flexible beam torque wrenches have a handle that pivots out here. That pivot point has to do with the length of the lever. And so by keeping that handle centered on that pivot and not letting it touch the inner rod, you're maintaining the length of the lever at the proper point, which will give you the proper amount of torque. On this one here, you've got the handle that pivots on a center point. That's the length. It's maintaining the proper length. So you always want to keep that centered as you're using this. Now, let's talk about accuracy. These torque wrenches and most torque wrenches are the most accurate in the middle of their scale. So, for example, this 0 to 25 inch-pound torque wrench would be the most accurate when it's halfway between 0 and 25. And it becomes less accurate as it approaches 0 and as it approaches 25. So if I wanted to torque something to 10 inch-pounds, I would pick the smallest torque wrench scale that I have. This one goes to 10, but so does the one that goes from 0 to 50, and so does the one that goes from 0 to 100. But the one that goes from 0 to 25 will give you a more accurate reading. So for manual drivetrain and automatic transmission work, you're going to need a lot of torque wrenches to cover the different torque specs that are out there. And this is not just true on these old flexible beam style torque wrenches, but it's also true on the clicker style torque wrenches, the electronic style, the dial gauge style, and I'll show you those here in just a moment. So let's get these off to the side. In my class, we will be using a lot of these in or when we overhaul front and rear axles for pinion preload and total preload. Okay, the next torque wrench I want to show you is the electronic version. So I've got a 1/4 inch drive, and what that means, it's got a 1/4 inch square head on it right here for 1/4 inch drive sockets. And this will measure between 24 and 240 inch-pounds, which is the same as 2 to 20 foot-pounds. So real small increments. This one's from Snap-on. Here's a 3/8 drive one that's also from Snap-on. And here is a 1/2 inch drive one from Snap-on. So if I turn those over, you can see the differences in the size of the drive there. All right, now the ones with the red handles only do torque. The ones with the gray handle will do torque plus an angle. If you have torque to yield bolts that you need to use, then you'll use a torque angle meter rather than just a torque wrench. The specifications will have you tighten it to a certain torque and then turn it so many degrees of a 360-degree circle. So it might be, I don't know, just for example, 50 foot-pounds plus 90 degrees of rotation. This tool can measure that. Now, these tools in my toolbox were an early version of Snap-on's electronic torque wrenches. I don't use the clicker style torque wrenches in my classes because everybody forgets to unscrew the clicker style adjuster knob and bring it back to 0. And if you forget to bring it back to 0 after every time you use it, it comes out of calibration very quickly. So in other words, it becomes less accurate. These work really well except for one major flaw, and that is there's a battery cap here on the end where the batteries go. And that cap has a conductor in it, of course, for the batteries. If you leave that screwed in, and you get the beep where it powers up and it'll auto power off, the batteries run dead in like a week. They don't last very long at all. It has a parasitic draw that runs them dead. It drives me crazy. So to keep the batteries from going dead, I recommend that you always, when you're done using it in my class, that you unscrew the end knob here about a quarter of a turn, a fourth of a turn. Now another problem that I don't like, or that I have with this style of torque wrench end cap, is that when students are using this torque wrench, they don't hang on to the handle here. The black part right there is where your hand is supposed to go. There's a notch right there that's supposed to be the center of your hand. Instead, they put their hand out here on the end of the housing to get more leverage. And that twists and pulls on the battery cap, which in a lot of cases causes it to open circuit, shut off the torque wrench, and the students are sitting there waiting for it to beep as they're turning it, and sometimes it doesn't beep, and they end up breaking off the bolts because they didn't realize that in the middle of torquing their whatever bolt they're tightening or nut, the torque wrench shut off. And so it's a really bad design. I hate these things. But if you will just hang on to the handle rather than the end cap, you will avoid that. So keep that in mind as you're using these. When you're done with these, once again, open the battery cap about a fourth of a turn, wipe everything off, put it back in my toolbox. These, when you turn them on, there is a power button right here. You push and hold to shut it off. There's a U button right there for units. And so right now we are in foot-pounds. If I hit the units button, then it changes to Newton meters. And then if I hit it again, let's see, foot-pounds. Oh, I'm sorry. Foot-pounds, inch-pounds, and Newton meters are the three units that this particular torque wrench has. And then of course you've got the plus buttons to increase the amount of torque or decrease the amount of torque delivered. These do auto power off. When they do auto power off, as long as the battery cap has not been unscrewed, it'll retain memory of your last torque. So when you turn it back on, it'll remember it if you need to continue torquing with that particular torque. If you unscrew the cap like I want you to, it'll erase the memory and you'll have to punch it in again. But that's the only way I can keep these things functional. So keep that in mind. That's the early style snap-on torque wrench. Now the later style snap-on torque wrench, they fixed the problem with the battery cap end and the housing. They made it all out of some sort of metal. The battery cap here on the end has right-handed threads rather than left-handed threads. So it won't come unscrewed as you're tightening clockwise components. This particular one is a 3/8 inch drive. This one is a 1/2 inch drive. Both of these do torque and angle, and they have the same power and units buttons, the up and down buttons. They have a backlight button also. The unique thing about these torque wrenches is that when you first turn them on, so we do not need to unscrew the battery on these. It does not run the battery dead. The battery stays battery stays alive on this one. So if we turn on the power, notice it says angle zeroing set still, and that's because this measures torque angles also. I found that just holding it by hand doesn't set it still enough. You've got to physically set it down on something where it's not going to roll, and then it'll switch to a screen after it self-calibrates here where it's ready to measure torque. And this one has the same foot-pounds, inch-pounds, newton-meters. Seems like it has one more. Foot-pounds, inch-pounds, newton-meters, kilogram, centimeters is the other one. And then DNM, I don't know what that is, and then back to foot-pounds. So this has, what do we say, 5 different units of measure there. So when you're using these newer style torque wrenches in my class, make sure you wipe them off, turn them off also. You have to push and hold the power button to shut it off. Push and hold. And that's the same on these earlier ones here too. Now, none of these torque wrenches here are designed to do anything other than tighten a bolt or a nut to a certain torque. These 3 torque wrenches here will beep and the handle will vibrate when you've reached that torque. These will beep, the handle vibrates, and there's lights on the side here that'll go from yellow to green to red. Now, one thing you really need to pay attention to is that none of these torque wrenches will stop you from over-torquing whatever you're trying to tighten. So when it beeps and vibrates, you need to look at the screen there because you probably, if you weren't watching it as you were torquing it, you probably exceeded the torque. So what you need to do while using this style of electronic torque wrench is while you are torquing it, you need to watch the numerical value there besides waiting for the beep and the flashing lights and the vibrations, and stop pulling on the handle when you reach your specific torque. Otherwise, you will over torque it, and yeah, it'll beep saying, yeah, it'll beep as you passed the proper torque and you kept on pushing, and sometimes it can make quite a difference. All right, so that's the electronic style torque wrenches. I really like these not so much, but no clickers. Just don't use a clicker. All right, all of these are also inaccurate at the outer edges of the scale that they're designed to measure. So as I said before, this torque wrench measures between 2 and 20 foot-pounds, or 24 and 240 inch-pounds. This one measures between 5 foot-pounds and 100 foot-pounds, and this one between 25 and 250 foot-pounds. So every one of these can reach 25, well, this one does 24 foot-pounds, but keep in mind you want to grab the torque wrench, so you're going to need multiple torque wrenches. You want to grab the torque wrench you want to grab the smallest scale torque wrench you can use that will put the measurement or the torque you're trying to torque something to right in the middle of its range. So if I needed to torque a lug nut to say 100 foot-pounds, this one goes between 5 and 100 foot-pounds. So yes, it would hit 100 foot-pounds, but 100 foot-pounds is at the end of this one's range, and so it will be inaccurate at 100 by a certain percentage, 3.5% or whatever it is. This one, 25 to 250, 100 is somewhere in the middle of that, so that would be more accurate. So keep that in mind as you're using torque wrenches. When you put these back in my box, keep in mind these are very expensive. You don't want to set other tools on top of these. Keep them isolated by themselves. You can set these on top of other tools, but not other torque wrenches. All right, now let's get these out of the way. By the way, there are precision spring scales in various spring tensions that you can still buy today from scientific supply houses to replace the old fish scale style springs from the past. Now let's bring in the dial style torque wrench. All right, this flexible beam style torque wrench that claims to measure between 0 and 25 inch-pounds of torque is fairly inexpensive. I think you can buy these anywhere between $20 and $35, depending on where you buy them. So an inexpensive and good way to begin with, but keep in mind that these can be fairly inaccurate. If you look at the scale on these, if that needle is not pointing at 0, when you start, you'll need to compensate by how much it's off when you're taking your measurements. And chances are, if it's not pointing at 0, somebody has maxed out. They've run this needle all the way over to one side to where it hit and it bent the shaft itself. So never ever run these all the way to where they hit either end of the maximum of their scale. Now the same is true of these newer style dial torque wrenches. So I have 3 of them here of different torques. This one is from 0 to 30 inch-pounds. This one is 0 to 75 inch-pounds, and 0 to 150 inch-pounds. They're all basically the same other than what scale they go to. So let's take a look at the finest one, the smallest one right here. And let's see, this is a Snap-on TER 3FUA, and I really like this torque wrench. As I said before, it is a dial style torque wrench. It has this dial that rotates. These are the most accurate by far of any of the torque wrenches out there, but they're also very expensive. So this particular one is a 1/4 inch drive or 1/4 inch drive, and it measures in inch-pounds and Newton meters. If we look at the scale here, the black inner scale is inch-pounds, the outer scale is Newton meters. All right, so another neat thing that this scale has is it has a min-max dial. So this little dial right here, you can set it to 0. So we have a scale just like a dial indicator or a rotating scale. So I've got the red pointer pointing right at 0, and then I'll put the min-max dial on there, and then as it measures a torque, that silver needle will measure and keep the maximum torque that you reached, and the black or the red tipped one is the actual torque that you're using at the moment. So why do I like these so much? They're very accurate, and they work really well on axles as far as setting them up. If you want an accurate pinion bearing preload measurement and an accurate total turning preload measurement, these are the way to go. Now these work okay, but you really do get 2 different readings with these 2 different torque wrenches on the same part. So let me give you an example here, or let me show you an example. Oh, by the way, the scale on this only goes from 0 to 30 inch-pounds. So the red needle right now is pointing at 0. The opposite side down here is 30. When you reach 30, you need to stop turning it because you need a bigger torque wrench, a higher capacity torque wrench. If you continue turning it beyond that point, you can cause damage to the calibration of this torque wrench. So if it takes more than 30, then we'll have to get our torque wrench that goes from 0 to 75 or 0 to 150 Newton meters. Sitting right here, I have a Toyota Tundra front axle. I've got a 30 millimeter socket I'm going to put on the axle nut, and we are going to see what the breakaway torque is and what the constant rotational torque is on this axle. Okay, so since the rotational torque is unknown at this point, we're going to start with the largest of the three torque wrenches, the flexible beam ones. So the 0 to 100. I'll put an adapter on here to go to 1/2 inch. We'll put that on here. Toyota specifications call for the breakaway torque, whatever the breakaway torque is. That's what they're looking for, where other axle manufacturers might call for the constant rotational torque. So let's look at the breakaway torque. The breakaway torque is, where does this needle go? Where does it reach when the pinion flange here starts to rotate? Here's 20, 25. Whoops. Let's try that again. We're at 0. Okay, so just as a reference, it's looking at about 25 inch-pounds of breakaway torque. So now let's take that measurement with the 0 to 50 inch-pound torque wrench. Looks like it breaks away at around 20 to 22. All right. So because that is so close to the 25 inch-pound, I'm not going to use the other torque wrench to take that measurement. But our dial style torque wrench can go to 30 inch-pounds. So let's put the socket on here. Get everything zeroed. And let's see what we get. Looks like about 20 is where that breaks away. So 20 inch-pound breakaway with this, about 22 or so with this one, and about 25 with the other one. Now when we're talking a specification that can be pretty tight, that can make quite a difference. This also can make the difference between bearing preload that's within specification and one that's not within specification. So the more accurate the reading, the better off you will be, the better your repair will be, and the happier your customer will be. Once again, when you are done using the torque wrench, put it back in its box that it came in. Don't just throw it in a drawer or set it on the workbench and pile parts on top of it. Very expensive. These were around $350 each versus the $30 each for these other ones. But for precision work, if you're constantly doing transmission and axle work, these are definitely the ones to have for the long haul.